If stoichiometry keeps going wrong, even when your math is fine, it's usually because of one of these common mistakes. Let's jump right in and let's fix those mistakes. Mistake number one then is using the mole ratio too early. So one of the most common stoichiometry mistakes is trying to use the mole ratio before converting to moles. Mole ratios only compare to moles. So if we're given an amount in grams, the mole ratio can't be used yet. The first step is always to convert the given quantity into moles. And once you're in moles, then the mole ratio applies. So it sits in the middle of the process. It's not a shortcut. You have to, if you start with grams, you must go to moles first. So for example, in this problem, we're given 4.0 grams of hydrogen gas. So if we just went 4.0 grams straight into the mole ratio to get the moles of water, which is what's being asked for in this question, this is wrong because we've skipped the conversion to going to moles. So we need to first go convert that to moles of hydrogen gas, and then we can go back through these steps here. And so that is one of the really big mistakes that I find students make, is using the mole ratio too early. Keeping in mind, you need to keep in mind that mole ratios only work between moles. Mistake number two is not balancing the equation first. So another very common stoichiometry mistake is using a mole ratio from an equation that isn't balanced. Mole ratios don't come from chemical formulas, they come from the coefficients in balanced equations. So if the equation isn't balanced first, the mole ratio is going to be wrong, and everything after that is going to be wrong too. So looking at our equation here, this is not balanced. So if we were to use the mole ratio of 1 mole of hydrogen to 1 mole of oxygen to 1 mole of water, this would be incorrect because the equation is not balanced. But if we balance the equation with a 2 here and a 2 here, then we get the correct mole ratios. So 2 moles of hydrogen react with 1 mole of oxygen to produce 2 moles of water. And so the balanced chemical equation is where the mole ratios come from. So if it's not balanced, you are not going to have the correct mole ratio. Moving on to mistake three. Mistake number three is using the wrong mole ratio. So even when the equation is balanced, sometimes students, I find, will often use the wrong mole ratio. And this happens when you grab the first ratio you see instead of choosing the one that matches the substances in the question. So you have to look at what you're given and what you're looking for and picking that right one from there. So for example, in this problem here, if we get out our highlighter, then we're looking for moles of water and we're given moles of hydrogen gas. So our hydrogen gas is here and our water is here. Okay. Now we have a bunch of different mole ratios in here. We know 2 moles of hydrogen gas, for example, react with 1 mole of oxygen gas. We know 1 mole of oxygen gas produces 2 moles of water. And we also know 2 moles of hydrogen gas produces 2 moles of water. So looking at a problem, we need the one with water and we need the one with hydrogen gas. So this is the only correct mole ratio to use here. Both of these two are not the correct mole ratios, and they would give you the wrong answer if you were to use this to solve this problem. So you have to be really careful, and I suggest use a highlighter and highlight the ones that you're looking for in your problem. because that will save you from picking the wrong mole ratio in your answer. Moving on to mistake number 4 then is forgetting the final conversion. So another very common mistake is stopping after the mole ratio and forgetting to do that final step, that final conversion. So the mole ratio will only give you moles. And if you have a question that doesn't ask for moles but asks for a different unit, you have to do that conversion at the end to get the correct answer. So for an example, in this question, we're asked for grams of water and we're given moles of hydrogen gas. So if we just went 3 moles of hydrogen gas, we use our mole ratio of the water to the hydrogen gas. And then because that's a 1-to-1 mole ratio, we go, okay, 3 moles of water. Then this is not finished. Okay, we don't want to stop here because we are looking for grams of water. And so we need to take that next step to convert to grams of water in order to finish our question off. So make sure your final units, when you're done all of your Stoic, match what is being asked in the question. Mistake number 5 then is multiplying by coefficients in the final gram step. And this one I see all the time. And it's a really big misconception. So what I see is that students correctly use the mole ratio, but then they multiply by a coefficient again when they're converting between moles to grams. So coefficients are only used in mole ratios. Once you're converting moles to grams, the mole ratio is done. The coefficients no longer apply and they've already done their job, so you don't use it twice. So for example here, when we're converting and we've done our problem and we're going from moles of the hydrogen gas and then we're using our mole ratio to find our moles of water. This step here is where I often see this misconception. So what students will often do is they'll go mass is moles times molar mass, and then they'll put in the number of moles, and then they'll put in this case, 2 times 18.02. So this is not correct because we've already used it in the mole ratio here. So using it here again is going to basically double your answer. So we do want to make sure we're only using the molar mass for one of that particular substance. So coefficients are for mole ratios only. And finally, mistake number 6 is not checking whether the answer makes sense. So the last mistake I want to mention is when you're skipping that quick check at the end. You should be doing a little quick check at the end of your stoichiometry problems to make sure that they make physical sense even before you worry about precision. So you don't need to redo the whole problem. A really quick, takes 5-second kind of check is enough. And something you want to check is, for example, if you start with a small amount of a reactant and then you end up with a huge mess of product, that's giving you an indication that something could have gone wrong. If your final units don't match the question, then again, something has gone wrong. So you do want to make sure that you're going through a checklist and just ask yourself, do the units match the question? Does the size of the answer make sense? And finally, did I use a balanced chemical equation? So those are some really nice, easy things to go through and double check before you hand in your work or before you're finished the problem, because it can help you catch some of those mistakes before you even hand your work in. So now that you've seen the most common oh my goodness, the word. Now that you've seen the most common stoichiometry mistakes and how to avoid them, be sure to go back and check out the rest of the playlist to keep building your skills. The full series is linked on the screen now and in the description below. Thanks for watching, and we'll see you in the next one.